Okay, so we need to write a function which takes in two strings, string 1 and string 2, and it's going to return an integer. More specifically, we're writing a function called stringSearch, which takes in two strings we will call a haystack and a needle, and it's going to return some index. Okay, so what do I mean by that? Let's get specific. Let's give an example. We will use the example, hello world. Hello world will be our haystack, and our needle can be the string OR. So I need to find where this needle appears inside this haystack, and if it doesn't appear, I'm going to return -1. So I'm looking through, okay, I find OR, it does exist in here, so what's the indice? That would be 0, 1, 2, 3, 4, 5, 6, 7. So this should return 7. So what would be a possible approach? I'm thinking we need to compare each of these, so we need pointers to each one of these strings. And we'd kind of look for like, okay, are these the same? They're not. So let's look at this next one. Are these the same? They're not. No, no, no. Okay, we have a hit. So now we got to look at each one moved over. They're not the same. So we go back here, start this one back at the beginning, and go to the next one. Not the same, not the same. All right, we got a hit. We move them both forward, and that completes the needle. So we would want to return 7 then, or the index here. So that to me sounds like two loops. So we would loop through our haystack, and then inside that loop we would loop through the needle. Loop through the needle. Okay, and we're going to have pointers to these, so I'm just going to call this the haystack pointer, I, and the needle pointer, J. Okay, so I know which indice I'm looking at. Okay, so what do we want to do? Well, like I said, we want to compare these two. So let's say the other case where they're not equal to each other. If, let's say the haystack at I plus J does not equal the needle at J. Now I do I plus J here is because like when I do have a hit, I need to increment them both. So like this would be +1, so that would be +1 here too. So that's why I need to keep track of both of them there. And I'm looking at the needle only at that iteration. So if they're not the same, well, I can just break out of this loop and go to the next iteration. Like, oh, these are not the same, go to the next. So here we break. Okay. Now, if they are the same, we would just keep going. But the other condition we need is if we've reached the length of our needle. So we can track that here, where if J plus 1 triple equals the needle's length, needle dot length, then we can just return our I index, the haystack's index. Here we would just return I. Okay, and the last thing we want to do is for the case where I don't find my needle at all in the haystack, we are to return -1. So I would probably just at the very end, after I close out my loops, I would just have return -1. So that way, if I never find my needle and I'm able to go through my entire haystack, I would just return -1, and I think that seems like a good approach. So let's take a look at what that would be in code. All right, let's code out our string search approach. So we're going to write our function const string search, and that is a function that will take in a haystack string and a needle string. And we said we were going to loop through the haystack, so let's write that. for let I equal 0, while I is less than the haystack length, I plus plus. And we also said we're going to need to loop through the needle for each iteration of our loop through the haystack. So for let j equal 0, while j is less than the needle.length, j plus plus. Okay, and we said there's two cases that we're going to be looking out for. One where the needle, where we're looking at the needle and where we're looking at the haystack, if they are not equivalent to each other, we can break out of that inner loop right away. So let's look for that first. So if the haystack at j or I plus j, because we want to keep track of which character we are looking at, if that is not equivalent to the needle at j, we can simply break out of the loop. Boom. Next, if we're able to complete the entire inner loop, that means we found the needle, and we can return the indice of where we are looking in the haystack loop. So if the j plus 1, if that is equivalent to the needle length, then we can return I, or the index of the haystack. Now we need one last case where we complete both of these loops and we don't find it at all. So we're just going to return -1 for that case. And that looks pretty good to me, but let's test it. I'm going to grab my code and go over into Node, copy and paste it right there, and let's see, stringSearch hello world, and let's try OR. We should get 7, which we do. And let's test the negative, stringSearch hello world, and we're going to look for the string 8. And it should return -1, which it does. So it seems like we've got some working code now. Let's see if we can optimize it. So I don't see a way that we can get around using these nested for loops. However, what does strike me is that we don't actually need to loop through the entirety of the haystack. You can imagine a situation where the needle's length is longer than the haystack, and we don't have to look at every character in the haystack to actually figure out that, no, there's no way that needle can be in there. So we need to actually loop from the haystack less the needle. So what I mean by that is we can go from here to less the needle dot length -1, because I'm pretty sure we got to keep track of that 0 indexed arrays. And then we don't have to go through the entirety of the haystack. So let's test this out. I'm going to kill my node, start my node, and paste in my string search. And let's see. String search of hello world. Let's try RLD. So we should get 8 in this occurrence. And we do. And again, let's try string search with the negative, always test. Each of these cases, we'll again search for the string 8. And we should return -1. And it looks like we do. So at the end of the day, it looks like we have here a big O of n times m, where n is the length of the haystack and m is the length of the needle. Don't think we can do too much better than that, aside from the little micro optimization we made there on line 2. So that's how I would solve string search.